So you've started writing some Go, but have you ever stopped and wondered what makes Go code really feel like Go? It's more than just getting the syntax right. It's about writing code that's truly effective and idiomatic. Well, today we're going to break down those foundational principles straight from the official documentation. Let's get right into it.
This quote from the source material just nails it, doesn't it? You can't just copy-paste your old habits from C++ or Java and expect a masterpiece. Go was designed from the ground up with a different philosophy, one built on simplicity and concurrency, and that gives it a completely unique character.
So what's the secret sauce here? What does it really take? It's not just about memorizing a bunch of rules, it's about a fundamental shift in your mindset. It's about learning to actually think in Go.
And to help us do that, here's our game plan. We're going to start with the core philosophy, then we'll dive into some super practical stuff like formatting, naming, and control structures, and finally, we'll take a peek at what's coming next on this journey.
All right, first things first, we have to talk about the philosophy, because before you can even begin to write idiomatic Go, you've got to understand the thinking that shaped the language in the first place.
Look, the big takeaway here is really simple. Stop fighting the language. When you lean into Go's properties and its conventions, your code just naturally becomes clearer, way more efficient, and a whole lot easier for anyone else on your team to pick up and maintain.
Okay, let's get into some really practical stuff. One of the very first things you'll notice in the Go community is a refreshing lack of arguments about code style. And why is that? Because Go takes a pretty radical approach. It just lets the machine handle it.
And this is the secret weapon, Go FMT. It's a command line tool that automatically reformats your code into one single official style. And this isn't just about making things look pretty. It completely eliminates those pointless debates over tabs versus spaces, so teams can focus their brainpower on what actually matters, solving problems.
And here's a perfect illustration of its power. Just look at this struct. The comments are all over the place. Now you could waste time lining them up by hand, or you could just run Go format. Boom. One command and everything is perfectly, beautifully aligned. It just works.
Now, that same principle, this idea of removing ambiguity and enforcing clarity, it extends directly to how we name things in Go. See, in this language, naming isn't just a stylistic choice. It's a core part of the language with real semantic meaning.
And this right here is the single most important naming rule you have to burn into your brain. Capitalization controls visibility. That's it. If a name starts with a big uppercase letter, it's public, or exported in Go terms. If it's lowercase, it's private. This isn't a suggestion. The compiler literally enforces it. It's that simple, and it's that powerful.
This whole philosophy of clarity applies to package names, too. The convention is to keep them short, lowercase, and to the point. Why? Because it makes the code you write so much cleaner. You end up with something like bytes.buffer, which is just way easier to read than, say, byte_utility_helpers.buffer. It also dramatically simplifies common patterns, like getters. Instead of cluttering your code with getOwner and setOwner, you just use the name itself. The private field is owner with a lowercase o, and the public getter method is owner with a capital O. Capitalization does all the heavy lifting, keeping the code incredibly clean.
And this elegant simplicity continues with interfaces. The standard convention for an interface with just one method is so simple. You just add ER to the method name. So, a type that has a read method, well, it's a reader. One that has a write method is a writer. It creates these wonderfully clear names that tell you exactly what an object can do.
Go's whole philosophy of less is more even extends right into the very syntax of its control structures. It's all about reducing the noise and letting you focus on the actual logic. One of the very first things developers coming from C or Java notice is, where are all the parentheses around the if statements? It might seem like a tiny detail, but it's a very deliberate design choice to remove visual clutter, making the logic itself much easier to see and follow.
And Go's if statement is just incredibly versatile. Beyond the simple form, this second one, the if with an initializer statement, is pure, classic, idiomatic Go. It lets you define a variable and check it in one single clean line. But just as important is what you don't see here, a big nested else block. The convention is to handle your errors first and then return, which lets the main logic, the happy path, flow straight down the page. It's so much easier to read.
So we've just covered some really foundational principles, the right mindset, the essential tooling, and some core syntax. But trust me, this is really just the beginning of the journey to writing truly effective Go code. Once you've got these fundamentals down, the real fun begins. Building on this foundation, the journey continues by exploring things like functions that can have multiple return values, mastering data structures like slices and maps, and then, finally, tackling the one topic Go is famous for, its simple yet incredibly powerful approach to concurrency and error handling.
And that leaves us with this one last thought, a thought that really gets to the very soul of Go. The core concurrency philosophy is this: do not communicate by sharing memory. Instead, share memory by communicating. If that idea intrigues you, if it makes you want to know more, then you are definitely ready for the next step. Thanks for joining this explainer.